Hello, my name is Burak. I'm a sophomore computer science student at Bilkent University. And in this video, I'm going to be talking about my Physics 101 lab project. My project is about the analysis of the period of motion on a spring pendulum. The main purpose of my experiment is to examine the effects of mass, spring constant, and gravitational acceleration on the period of a spring pendulum. To do this, I will use 3 springs with different spring constants, masses of 10, 20, 50, 100, and 420 grams, a vertical hanger, a stopwatch, an air table, and a wooden cube with 2 different inclination values. First, I will talk about the theoretical background and stages of the experiment. According to Hooke's law, there is a restoring force that is directly proportional to the displacement of the object and acts in the opposite direction. Using this in the vertical plane, the constant of the spring can be found by equating the weight of the object to the restoring force, since there is no additional force other than these. Furthermore, Newton's second law can be combined with Hooke's law to find the period of a spring pendulum. The experiment consists of a preliminary and 3 main stages, which are A, B, and C. The aim of the preliminary stage is to calculate the spring constants of 3 springs by equating their weights to the restoring force of the spring. For this purpose, first the initial length of the springs was calculated, then the springs were suspended vertically, and different masses were suspended at the ends. Then the extension of the springs was calculated, and it was observed that the spring constant changes more consistently as the mass increases. So the spring constants calculated for large masses were averaged to calculate the correct spring constant. In part A of the experiment, the effect of mass on the period of the spring was investigated. For this purpose, the spring whose constant was calculated in the preliminary stage was suspended vertically, and then 4 different masses were suspended respectively, and a simple harmonic motion of 10 periods was performed. Then the average experimental periods were found for each mass. Then the theoretical period values for each mass were calculated using the formula of period. According to the results obtained, as expected theoretically, the period of the motion increased with the increase in mass. However, the increase didn't occur exactly as in the formula because the springs were not ideal. There was an air resistance, and errors occurred in the period measurement. In part B of the experiment, the effect of the spring constant on the period was investigated. For this purpose, 3 different springs whose constants were previously calculated were made to make a simple harmonic motion of 10 periods with a mass of 500 grams in the vertical plane. Then the average experimental period for each spring was calculated and compared with the theoretical period obtained using the formula. According to the results, just as expected theoretically, the period of the motion decreased with the increase of the spring constant. However, the decrease was not realized exactly as in the formula for the same reasons. In part C of the experiment, the effect of gravitational acceleration on the period was investigated. For this purpose, a frictionless environment was created with an air table, and 0.1 g and 0.16 g values were obtained using a wooden block. Then the pucks, each of which was 420 grams, were connected to each other with a flexible spring whose constant was calculated, and one of them was kept stationary, and the other was made to make a simple harmonic motion, and a period of 4 periods was measured. Then comparisons were made by also using the period of the same mass at g acceleration. The results obtained are very close to each other and to the theoretically calculated value, and differ only by the 100th% of a second. Therefore, no effect of the gravitational acceleration on the period was observed as theoretically explained.